My name is John Whaley, and I'm very excited to be here. I've been in this position quite a few times, getting to judge, but this time I get to actually watch. So the pressure's not on me, it's on the three judges over there. Prior to this, the biggest event or contribution that relates to this, I was one of the business advisors for the Goldman Sachs 10,000 Small Business Initiative. And, you know, the pitch was what it was all about. So I'm very excited for each and every one of you. Believe me, each day when I spend 45 minutes in traffic taking my kids to school as a Tiger Dad, I appreciate your innovations, okay? So we're going to get started without further ado. I'm going to bring up the first person who I know is ready to go. And you know the rules, you know how it goes. Best of luck. Here we go. First up out of the box, we have Laura Graham with, Laura's with HDR.
Wait, where? From beginning? No, from current slide? Okay. Are there any seats? Are there any seats? Are there any seats? That is a common question that bus drivers, commuter bus drivers, get asked on a daily basis from their passengers. Passengers want to know, are there any seats before they board that bus? So our focus today is going to be on the commuter bus. So on the commuter bus, you've got passengers who are riding for about 45 to 60 minutes to get home. And they want to make sure that they have a seat. They want to be comfortable. They don't want to have to stand that whole way home. So the big question is, are there any seats? There are 45 seats on the bus. So as passengers are boarding the bus, they ask the driver, and a lot of times the driver will ask passengers, but there's seats that are stuck in the back of the bus. And sometimes the driver doesn't even know, and people end up standing or missing the stop because they didn't know. So drivers are faced with a lot of challenges. They have traffic. They have people asking questions. They have people paying fares. They don't really have time to keep up with, are people actually, how many seats are left and how many people have boarded up until this point. So my invention, seat sensor technology. It's a sensor that will sit in the seat, so when somebody actually sits in the seat, it'll register that that seat is now occupied. Now this technology is not new. This is technology that you're seeing every day already in your own vehicle with airbag technology. So once you sit down, that airbag sensor goes off. If you're in a crash, then it knows somebody was there and the airbag deploys. 75 pounds would be the minimum that would be required in order to trigger this sensor for the driver, and it would relay up to him, and then the driver would then know, with the configuration on the bus, how many seats are available, where those seats are available, and he can deploy the person, the passenger getting on to go there. Now this is very similar technology to what you see when you book an airplane ticket. You can see what seats are occupied and what seats are vacant. So as passengers are getting on, he can say, hey, I've got 5 seats left. This is where they're located. This is going to make boarding much more efficient than it has been in the past, and this is going to tell the driver exactly where these seats are. Now once that bus has actually reached full capacity, he's going to have the console in the front, and it's going to tell him exactly, it'll be right there, and it'll tell him exactly where to go. It'll tell him when that bus has reached full capacity. It'll tell him where those seats are. And then so once the bus has actually reached the full capacity, they'll be full in the front of the bus. That way, as people are waiting and they're standing there, they can see, hey, that bus is full, I don't want to ride, or hey, there are seats I can get on, or hey, I'm willing to stand. This keeps passengers from constantly asking that, is that full question? So these are passengers getting on the bus. They're going to tap their card, they're going to go sit down. The driver's now going to know exactly what seat they sat in, and so when he gets to the next stop, he's going to be able to say, hey, I've got this many seats left, and this is where they are, or hey, my bus is full, you need to wait for the next bus, or be prepared to stand. Why? Why is this important to you as an agency? Why is this important to you as a bus manufacturer? How is this going to improve our customer service and our on-time performance in the future? Well, one of the big things is we want to make our customers happy. And customer service is really important. It drives ridership, it keeps ridership going, it keeps people going. So once we get customers happy and we can keep them on the bus, or they know the bus is full, then they're not yelling at the driver when they realize that they can't get on. Also, people can make the decision to wait. This is something that you can use as an app later, so people can see real time how quickly that bus is filling up, and once they get to the end of the line, they'll know, hey, that bus is full, I need to plan ahead. The biggest thing is to improve on-time performance. There's a 3 to 5 minute dwell time for people constantly asking, are there any seats left? Are there any seats left? Let's move on-time performance and make service more efficient, because at the end of the day, that's really what's going to save you money. And money is the key driving factor right now. Budgets are tight, finance is tight, so every little cent counts. That money then can be rolled into more service, better service, more improved service for your customers in the future. Now, this is something you can implement today with your fare card system. As people get on, 45 seats, 45 taps, that means the bus is full. Now, passengers won't know the bus is full, but the driver will at least know that bus is full. But really what we need to focus on is the seat sensor technology. Because with that seat sensor technology, it not only tells the driver where those seats are available, how many are available, but it tells those passengers waiting that that bus is full. And that's where people get upset, when they get on and they realize that that bus is full. Now, the thing with this also is it is patentable with the U.S. Patent Office. Depending on how you implement this technology, it can be patentable with a utility patent and or another version of a patent. So that's something to consider for the future. And also, why are we waiting? Why not do this now? This is something that we can use now to implement better customer service, better on-time performance, and to save money for the future and provide your customers with better service.
Thank you, Laura, for ending musical chairs for us. Okay, next up we have John Hattler of The T.
Okay. Hello, my name is John Hattler. I work for the Fort Worth Transportation Authority, and my geek presentation is to build a double-decker subway car. I believe that the reward of building a double-decker subway car is worth more than the cost. Who hasn't been there standing on an overcrowded train station platform waiting for the next train because the first train was full? Customers to the State Fair of Texas regularly wait a train or two. In fact, the Belmont Stakes, some customers waited 3 hours for a train home. The second problem I see is wasted space. Look at the side view of this New York City subway car. Underneath this train is a lot of equipment for operations. It's wasting space. If you can rearrange a train car and add just one more seat to it, the passenger growth is exponential. The other problem with this equipment is the fact that it's high-level equipment and it prevents more people from boarding the train. So what is the solution to these two problems? It's both simple and costly. But the reward is worth more than the ultimate cost. My idea is to board customers on both a high and low level platform onto a subway train car 2 stories tall at the same time. DART's super light rail vehicle allows customers to roll onto the train without the use of a ramp. If one were to lower the entire train to the same height, you could add a second level to the train car without interfering with current system restraints. The solution, a double-decker subway car, an idea worth taking on. This is an example of what it might look like to build a double-decker subway car. It's 2 stories tall, and you can get on and off the train with double the number of doors and double the number of passengers. So what's the advantage? An advantage that multiplies. If you can add an additional 500 seats to a train car, a total 10,000 customers per hour can board the train. What's getting in the way of making this dream happening now? Tunnel height, how tall a tunnel can get, tunnel width, how wide a tunnel is, and the fact that you need to redesign your train stations in order to accommodate. Well, this is the side view this is a section of a New York City subway tunnel. It's 14 feet tall and 11.4 feet wide. And those are the system restraints that rely and change from system to system. The other problem remains that you have to build new stations in order to fit and accommodate the train. So what needs to be done in order to bring this train into the station? Equipment with exact specifications need to be drawn. Station assets need to be redesigned in order to fit this train of the future into the station. Here we see a low-floor vehicle. I took the graphic drawing, copied it, and placed it on top of the other drawing as an example of what we're looking to create. Secondly, train station redesign would look something like this. It allows customers to board from both the upper and lower decks onto a train 2 stories tall. Basically, you're doubling the capacity of a train station without much work. So who would benefit from this? Cities like New York, Tokyo, and Hong Kong. Cities with more demand than current capacity allows. So what is the financial incentive? The increase in capacity adds station capacity and increases train usage, and it allows customers to avoid Tokyo-style overcrowding. So what needs to happen now? We need to establish a committee to study the issue. The committee needs to set industry standards for such equipment that would apply from system to system. To summarize, I identified the problem of human capacity and created a double-decker train car to solve the problem capacity needs of transit agencies worldwide. Finally, increasing the number of passengers who can ride the train increases usage. It also comes along with increased speed and functionality. It allows customers to have entry points on both the upper and lower level decks of a train station. And that is why the future of transit agencies should build a double-decker subway car. I do have some important people to thank, including my boss and the judges who took their valuable time today to help us out. Thanks so much, and have a good day.
All right, thank you, John, for bringing us high-rise transportation. All right, next up, we have Cam Leong of Metrolink.
Good afternoon. Today I'm going to talk about ambient light sensing. Ambient light sensing is not new. It's been applied in the automotive industry. Now, why ambient light sensing? We've been constantly told by our boss to save energy. So how are we going to do it? So I'm going to go through ambient light sensing. Ambient light sensing, as I say, is not new. And I'm going to go through the application, the design, and then what are the issues that we see in ambient light sensing. So what is ambient light sensing? Ambient light sensing actually looks at the real light as we see with our eyes. So it detects the same, it's detecting the same light condition as our own eyes. And how does it work? When it's daytime, we have basically 2 settings. One is dusk and one is dawn to determine when to switch on and off those lights. The best location of this ambient light sensor is at the front of the cab, where there's ambient light, where you can see the sunlight. And on a coach car, you can have it located at a windowsill. So when it's daytime, you modulate. When it's daytime, when you detect the light, you modulate the light at 50%. And that would save, sort of save energy by either dimming the light or you modulating it. And the other option is when it's daytime, you switch half the lights on and half the lights off. And of course, at night, you bring the lights back up. The other application of light sensing is mood sensing. You see a lot of that in the aircraft. And when there's certain time, like a day today, which is very cloudy, you want a different mood in the vehicle. What are the pros and cons of the ambient light sensing? Of course, with CFLs, we can dim it, but then you run into the issue of reducing the life of that the T8 CFL tube. So dimming of the ballast and maintenance of fluorescent lights is one of the main disadvantage of using when you dim the lights too much with CFLs. but with LEDs, there's no issue. So the other thing is about safety. When in the daytime, most of the instrumentation in the locomotive cab tends to be washed out. So in order to do that, you get an automatic light sensing. So how do you convince an agency to adopt this? Of course, you have to come up with benefit cost analysis and also the return on investment. And for those technical type, how do you do it? It's very simple. You actually use a photodiode or a photo sensor, go through your A to D, and then get your 2 set points, and then input it to a logic controller. And this is what the sensor looks like. I would recommend that you use a current sensing, which gives you a wider range on the 2 set points. So rail industry implementation, as far as I know, there's none in the United States. I was trying to say that there's none in Canada. But as I was walking downstairs with my lighting supplier, TDG, they actually implemented in Calgary. And what do we do for sustainability awareness? We recommend that APTA promote ambient light sensing and also involves all levels of government. And then also not only ambient light sensing, but promote other ways of conserving energy. And finally, is lighting right for your cab? In order to do it correctly, I recommend that you do it the first step right by installing LEDs. Thank you.
All right, thank you, Cam, for bringing new light to transportation. All right, so next up we have Zhiting Cai. Nope, I'm sorry. Let's back it up. We have Nicholas Latendre. There we go. Thank you.
Hi, my name is Nicolas Latendre. I am a mechanical engineer, and I'm here today to present you a new bus project, which is a conceptual design of an electrically driven 40-foot low-floor bus platform. At the agenda today, I'm going to talk to you about a project focus, the actual situation in terms of market and some design elements, the proposed solution, the benefits, and a brief conclusion. The project focused on 4 points, which is sustainable transportation, bus life cycle cost reduction, improved design interior, and application for hybrid series, electric, and trolley buses. Talking about the actual situation, in terms of market share, only 13% of the North American bus fleet is powered by electricity. One of the major causes of this situation is the capital cost of an electrically driven bus, which is between 35% to 70% higher than a standard diesel bus. Now, the first of the 3 design elements I want to talk to you about is the general design of an electrically driven bus, which is talking about, now I'll go talking about weight, where we have an uneven weight distribution on a standard bus, where 70% of the load is applied on the rear axle. Talking about accessibility, we notice that we have a bottleneck effect at the front of the bus caused by the restriction between the front wheelhouse. Now, let's talk about the proposed solution, which is a sustainable transportation solution. So, the proposed solution, it's a life cycle sustainable transportation solution. We're talking about life cycle cost reduction, new bus geometry, weight reduction, interior design improvement, and customer attraction and retention. Talking about life cycle cost reduction, we have a significant impact on the direct cost. We're talking about capital cost and operating cost. And also, the weight reduction will give us a significant impact also on the indirect cost. Our proposed solution, the weight target is around 20,000 pounds, which represent 25% of weight reduction if we compare to the similar bus in the market. The new geometry will have an even weight distribution with an increased wheelbase. So increasing the wheelbase will have a big impact on the turning radius of the bus. So to avoid this problem, we will have a front and also a rear steering axle. And the rear steering axle design is taking from design from an articulated bus already in the market. About the interior of the platform, but I can tell you that the geometry respects the APTA white book in terms of the standard geometry. Okay, in terms of interior design, you notice that the front door is now behind the front axle, which have a good impact on the accessibility to ADA location and also improve the loading and unloading time. Now let's talk about benefits. So the benefits are for the users, the transit agencies, and also the bus driver. So in terms of the impact for the transit agencies, the life cycle cost reduction is very important for them. So we're talking about fuel economy, lower maintenance costs, and less pavement damage. Other kind of benefits will also be in terms of improve customer attraction and retention, achieving sustainable transportation goals, and also improving bus driver engagement. We are now completing the preliminary design phase of that project. We are looking to receive some feedback from people in the industry. You're pleased to give me some. And also, we are ready to disclose more information to people interested in that project. So I would like to thank you very much for your attention. And we hope in 3 years we'll be able to present you the concrete solution that I'm talking about. So thank you very much for the project.
Great job, and thank you, Nicholas, for bringing lowriders, electric lowriders, to a place other than car shows. Thank you very much. Okay, next coming up we have Zhiting Cai, who's going to come up here and present. Thank you.
All right. Can I move the microphone a little bit? Yike. So like this, maybe? Because I'm short. So, who has heard the MTA song by the Kingston Trio? All right, let me tell you the story of a man named Riley. On a fateful but not necessarily tragic day, he moved to a city called Bospolis. In the morning of his first day at work, he was squashed into the corner of a commuter train. At night, he stood miserable in the cold rain for an hour, waiting for his bus to come. So, Riley saved the money to buy himself a car. Let's not talk about his guilt of carbon footprints yet. People of Houston, you know this so well. I-10, I-45, I-69, 280, 290, like you, poor Riley was stuck in traffic. Not until one day, when he saw his colleagues emerging from a secret gate in the basement of his company building, did he realize that there was a thing called the Intelligent Luxurious People Conveyor System, or PCS, that made Bospolis unique. He stood at the gate in wonder. In the station, there are multiple tracks running in parallel that can load passengers simultaneously. Whoever pulls his legs in and shuts the door first is moved to the queue ready to be switched to the main track. So Riley ran in and snatched his own small but comfy cab. But if you come with a friend or two, like you all do, you can choose to aboard a 2-person or a 4-person cab. These are all small-sized, lightweight carriers. Wait, but Riley didn't have a system map. How did he know where to transfer or to get off? No worries, absolutely no transfers needed. State your destination to the audio processing system, sit back and enjoy your trip. Track layout is similar to city streets, much like a grid or a network. This interconnectivity also increases the flexibility for route planning. And in addition, this system can be built either underground or elevated. Now, the cab started rolling onto the main track. Notice that the caps Riley cut off didn't stop nor slow down. How? Because the system commander knew where there was a space for Riley to come in. So the system commander is a supercomputer that oversees and controls the entire system. It knows the speed, location, and destination of every single cap. Input data come from both onboard and wayside sensors for better calibration and protection. And from these data, it does dynamic modeling, optimization, and prediction, and then commands all carriers in real time and with advanced planning. These know-all and look-ahead abilities are the keys to the efficiency of the system. Right, lots of calculations are needed, but today technology enables us to collect, transmit, and process this extremely complex information with ease. And therefore, we shall start thinking about transportation not only in terms of individual units, but as an entire computer-based intelligent system running decision-making algorithms. Let's not just conceptualize a transit system as interacting dots, but as one big centralized model. So you may ask, will the system ever reach its maximum capacity during rush hours? Yes, it may happen no matter how small the computer is, right? But additional tracks can always be added to a busy stretch to increase the capacity. And remember, track switching is done by computers. Every single cab will also talk to the cabs in front and behind to safeguard its speed consistency among its neighbors. These local communications are separated from the global communication and hence serve as a second-level protection. In addition, adding more stations will not compromise the efficiency because in a PCS, stations are branches, and therefore cabs that exit will not block the ones running behind on the main track at all. And because the cabs are very small, size of the tunnels or other infrastructures for PCS system can be greatly reduced. Just a fun fact, the sewage tunnels in New York City are large enough to run the system. Cabs are powered by electricity, and because they're running on tracks, electrification is much simpler and operation friction is low. And as you all know, low friction is good for energy saving. One more benefit that the traditional rail transit does not have is that the cabs run on demand. No empty vehicles have to run on a fixed schedule to pick up those few lost souls wanting to go home late at night. So, did Riley ever return? No, he never returned. And his fate is still unlearned. Where is our poor O'Reilly? He loves this intelligent, luxurious people conveyor system so much that he just keeps riding forever, day and night.
Thank you, Z-Team, for making it possible to text and communicate, traveling again, and repurposing the roller coasters from Six Flags. Okay, so the next person we have coming up, dun, 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 is Vicky Hoffman.
So good afternoon, I'm Vicki Hoffman, and I will be speaking today about the importance of automation and testing and how it can help asset management. But before I begin, I need to mention my company that paid to have me here. So I work for Orbis. Orbis is a veteran-owned small business, and we provide engineering services to government and commercial customers. And our R&D engineering group focuses on design and development of automated test equipment solutions, or BTEs as they are referred in transit. So as an overview, I will be presenting a mock scenario of how test maintenance is presently done, followed by an introduction to test automation, how this affects our scenario, and concluding on how you can also realize these results. So getting started, I want to introduce you to Matt. Matt works in maintenance, and he tests units as part of a maintenance schedule or because a unit is broken and is not working correctly. So Matt picks up a unit that he needs to test, and along with that, he picks up a paper procedure and a paper data sheet that he needs to fill out. So as he's following this test paper procedure for the device under test, Matt fills in his test results on the paper data sheet, which is a very critical step. Of course, while Matt is hard at work testing, he might have some friends stopping by, like Larry asking Matt what he's doing for lunch, Gary asking if Matt's heard the latest news, and of course there's always Rick who's counting down how many months he has left in his retirement. After each visitor leaves, Matt goes back to testing and he's filling in that all-important test data sheet. This human interface portion of Matt's job, recording the test data, is very critical. It's the difference of a passed or failed tested device. If any errors in writing test data points could put a failed device back into stock for use. So if this device is passed, it will go back into supply, or if it fails, it needs to go back in for repair. But the data will be manually entered into an asset management database. So what happens if automation is introduced? Most importantly, we limit that human interface and therefore reduce errors caused by manual data entry and potential entry of a rejected asset being placed into rolling stock. Test tolerances are upheld and measured by the test equipment and recorded by the automated application. The generated test data will automatically be saved into any type of asset management database, and it can save locally as a text or Excel file. And once this data is in the database, trending analysis can be done quicker and more accurately to determine if a certain batch of devices are all failing the same test, which would indicate a faulty component within a same device. So having test results automatically populate in the asset management database can tie into maintenance scheduling and planning. This way, maintenance scheduling can be more precise and geared towards targeted assets with certain trends. So let's go back and visit with Matt and see what happens when automation is introduced into his testing tasks. Right from the start, you'll notice the difference. Matt does not need to rely on paper anymore. No need for a paper procedure to follow since automation will step him through his test, but also no paper test data sheet. Since all test data results will automatically be analyzed and saved, there is no need to write any of these results down. If Larry, Gary, or Rick need help with the parallel process, no problem, Matt can help. The test will continue to run in the background, and if Matt needs to perform a visual inspection, the test will stay paused until his input is given. Once the test is done, there is nothing left for Matt to do. The test data automatically saves locally and to the asset management database. If needed, a results traveler sheet can be printed to be used with the device after being tested. So that's it. The data is now in the asset management database, and maintenance planning can begin. Trending of data can begin. Reports can be run. So many things can be done with this data that has been saved. So how can we realize these results? To start getting good data out of your asset management database, you need to put good data into it. The best way is to automate the process of data analysis and data entry by replacing your discrete standalone test equipment with an automated test solution. This will guarantee that good data is in your asset management database. As a result, there will be an improvement in your maintenance planning and scheduling, and you can begin the implementation of reliability-centered maintenance, and most importantly, increase the reliability of your rolling stock. So thanks for your time. Please let me know if you have any questions.
All right, thank you, Vicki, for making Matt, Larry, Gary, and Rick an automated journey towards retirement. That's excellent. Now, okay, so coming up next, we have Young Park with TriMet. All right.
Start on your first slide there. Oh, okay. Click on your slide. There. And then hit from.
Thank you. Good afternoon. My name is Young Park, and I work for TriMet in Portland, Oregon. Let's look at a fixed location warning device that could be used by transit providers and agencies to combat distracted walking. These are all too familiar poses in our streetscape of pedestrians and bicyclists distracted by their smartphones while moving. Smartphones have gotten larger, are becoming a fashion statement, and a critical component of one's wardrobe. When distracted walking and biking are mixed with large moving buses, it could become a recipe for disaster. Evasive actions by bus operators are not uncommon, and cell phone-related emergency room visits are also on the rise. Pedestrian warning systems are not widely used in the transit industry. While audible or visible warning systems are available, and you can find some of them on the expo floor, effectiveness is unknown. TriMet was awarded an FTA demonstration project grant to test the long-term effectiveness of these products. Bus approaching turn sight, BATS for short, was a last-minute addition. I was tasked to come up with a fixed location sign in 4 months with a budget of $5,000. Where could a fixed sign be installed and be effective in alerting pedestrians that a bus near them is turning? We gravitated to the Transit Mall on 5th and 6th Avenue. A test site was narrowed to the intersection of West Burnside and 5th. It is a busy, multimodal street with concentrated volume of pedestrians and transit. It is also the main gateway for buses entering the Transit Mall. It was critical to detect the turning buses from West Burnside to 5th Avenue. It is a dedicated bus-only lane with a capacity for up to 3 buses at a time. With a leading left turn phase, transit has priority. So what message should we provide to pedestrians to stop and do not walk as a bus is approaching? Fancy blacked out signs were contemplated, but removed for consideration due to cost and time. So we looked at off-the-shelf products with simple customization. We wanted LED, and we agreed on bus for simplicity. And we wanted this to be an experimental sign and not a signal. So we looked at color and chose yellow for warning. And we wanted the sign to flash for the duration of the left turn phase. And we decided on 68 LEDs with 4-inch character height and a 23-degree viewing angle. The final product is a 12-inch diameter sign. It is mounted inside a standard single-head housing unit, and we tasked the City of Portland signal shop to fabricate a simple bracket unit and band it. No holes. We quickly wanted to remove the units when the demonstration ends. So we added a shield around each unit to minimize glare, and fabricated 2 units, one for the east and west approaches to the crossing. And we installed these on top of the existing PET signal for maximum visibility. So we powered this up on October 1st of 2013, and BATS continues to function reliably. So let's look at how it works. Bus enters the left turn lane, the signal detects the bus and trips BATS, and it flashes for 2 seconds to warn pedestrians that a bus is approaching before the left turn phase turns green. And it continues to flash for the duration of the 15-second phase, and is turned off when the phase ends. So let's look at it again from the westbound side. And this maneuver is important as it is the blind side for the pedestrians. So once again, the BAT sign flashes, 2 seconds early, the bus approaches, clears the intersection, and after the phase is done, the unit is blacked out when not activated. So have we created an additional layer of safety for people turning around turning buses? We believe so and are continuing to analyze the data. Here's a typical PM peak hour snapshot. So what's next? Focus groups were recently conducted with operators, pedestrians, and riders to gather feedback and areas for improvement. Cameras are up, and we continue to gather data. A version 2 is also in development. We'll be adding an audible component to the sign. We're also looking at BATS perhaps being activated with right-turning buses. And if your agency is in need of BATS, let's talk. So in conclusion, look up, especially when BATS is flashing. Let's put away the smartphones and be aware of your surroundings. Videos are available on YouTube by searching TriMet BATS. Thank you very much.
Well, Young, you just put a lot of Boy Scouts of America out of business that were looking for that crossing guard award. But that's okay. That's good. Frees them up to do other things. Okay, so coming up next, we have, I'm going to get this right because he told me exactly how to say it, Gamaliel Anguiano. All right. Come on up.
Exit out of there.
Okay.
Start back up here. Do current slide.
I'm going to do this a little different. How's everyone doing? Oh, you guys can do better. Much better. My name is Gamaliel Anguiano. I'm transit manager for a small transit system in California. And I'm very passionate about propelling transit forward. Specifically, I want to make public transit safer for everyone. So I want to do that primarily by changing the way transit vehicles communicate with the vehicles we're first forced to share the road with. So how, you might ask, does transit currently communicate with other vehicles on the road? Well, we do that just like anybody else. Wait for it. Do that primarily through our, try to get the slides to keep up with me. Through, changing communication. I want to change the way we communicate with the vehicles we're forced to share the road with. And we do that primarily through our signal indicators. Signal indicators being in the form of brake lights and turn signals. Wait for the slide to advance here. But that is precisely the problem. See, we are using technology that was designed for automobiles and placing them on transit buses. That's like putting a bicycle helmet on a motorcyclist, on a biker. It just doesn't fit. It doesn't work. It doesn't carry over. For one, these signal indicators are far too small for our vehicles. Secondly, signal indicators like brake lights are actually a bit ambiguous. We don't know if this bus is slowing down or if it's come to a complete stop. And even if we could determine this, when the same signal indicators almost speak a different language when they're on the bus. I mean, think about it. Imagine a vehicle in front of you turns on his turn signals. We think, well, he wants to get in front of me, I best slow down and let him in. But let a bus turn on its turn signals, and what do we think? Oh, I better hurry up before this bus gets in my lane. And that creates a lot of the unsafe actions that affect the transit vehicle that are beyond a transit system's control and create a lot of the heartache and incidents that affect our transit system. What we really need is people to respect the transit bus, respect transit. Some states like Florida have invested millions of dollars in their legislature and infrastructure in attempting to address this very situation. However, I'm proposing an idea that's much more realistic, simple, and yet innovative, and doesn't cost the millions of dollars that it would take in infrastructure. But before I go into my idea on improving the safety of public transit through these signal indicators, I want to give you a little bit of the history about how this came around. I, too, have been stuck in traffic. And I noticed that traffic lights or brake lights come to you at waves. They start up somewhere up the road, and then finally everyone starts hitting the brakes just the same. But eventually, we become callous to these lights because they happen too frequently. But unfortunately, we become callous to the times we definitely need to come to complete stops. And that's gave me the idea that there was no way to indicate a difference between a vehicle that was slowing down and one that was coming to a hard stop. My innovation is that brake lights should go from red to bright red the harder a driver hits his brakes. That way you can know at the speed of light when a vehicle is simply slowing down and coming to a hard stop. This will improve the safety of public transit and reduce the number of rear-end accidents if we can distinguish this through the technology we'll place on our bus that already exists and improving it. Similarly, I think we can take this same approach and apply it to our turn signals. See, turn signals indicate an intention to enter a new lane. But as we stated before, people try to beat the bus. I'm proposing that the moment the driver turns the wheel, that these same turn signals start to flash brighter and faster and even scroll to show to the vehicles behind us that the movement of this bus into the lane is now imminent and that we should consider this before approaching from behind. It's my thoughts that such approaches will reduce the number of rear-end accidents and side swipes, the number 1 and 2 causes of accidents on public transit systems. And it's all because the increased amount of distracted driving. Brighter lights give better indication, farther advance of the movements and the intentions of a bus. We'll be able to distinguish a bus that's simply slowing down from one that's coming to a hard stop and motivate others behind us to also do the same. We'll also motivate others to yield to the bus as it attempts to approach the bus. Look at these two faces. I just want to take this slide to acknowledge my wife and the children for supporting me in this presentation. Thank you guys all.
right, I definitely want to thank you for helping us see into the future right now with that device. Absolutely. Okay, next coming up we have Adam Saki.
Okay. Okay, so my name's Adam Saki, and the presentation I have here today is to talk about the end of the car. And the way I see the future coming and just how it's naturally progressing is that the car that we know it is going to end. And so part of my presentation is we have a mission. By the 2024, we're going to eliminate all smog, all forms of congestion, and every single auto accident, fatalities, deaths, everything related to that. And it's okay, so how I was inspired by this is the view that's outside of my balcony in my apartment, just located right over here. And when you're looking at the Pierce Elevated here, you just see how cars are driving. It's, we like to think we're driving the cars, but really the cars are kind of driving us, and it's already kind of an automated process. And so the idea is that in the future, we're going to be driving these, it'll be driverless. It'll be all of the entire crowd will work together of the Internet of Things and Google cars working to end the idea of us having to drive. And we live in this on-demand culture. Right here, this isn't a shot from Uber. So Uber's already doing it. They're working on making an on-demand system where you push a button and the car knows where to go and it already knows where to take you. It's like Amazon. Amazon knows what you're going to buy before you end up buying it. Well, in the future, we're going to know where you're going even before you do. So you hop in the Google car or whatever the device is of the future, and it's driverless. It's completely eliminating the cause of all accidents is the human, whether you like it or not. And Uber's done a great job. They made it cool. They made transit cool again. They've done an excellent job. And the idea is that we can use their model for continuing the development of the system. So smog, the way I see it, it's already gone. This is what Tesla's developed, a wide range of network, which I call smog-free zones, where you can charge your car for free or whatever your device is in the future. And we like to think that this is kind of these driverless cars are this fantasy and changing the way. It's already happening now. We have Waze, which uses on-demand traffic management, Metropia, which actually tries to change the way when you drive, when you're going out, and when the next car will go. And so there's already big players in this game. Google's leading the way in all of this. Uber, Waze, they're all owned by Google as well. And Apple's even just introduced their CarPlay thing. So the idea is getting the smartness of the crowd and everything into the car to do dynamic modeling. And Tesla, everybody knows Tesla, they've done the Hyperloop. So these are major players that are already looking to completely transform the way we move, eliminating the car. And even you got the CEO of Ford, says cars in urban environments are simply not going to work. The Uber CEO says when eliminating the driver, the cost of taking Uber becomes so low that ownership will just disappear. And even our area councilman said that he bought his car because it could park itself. So, and we have a problem in governments, though, is that the city of Houston went on a witch hunt against Uber. I'm sure many other cities have had the same scenario where they invited him to City Hall and started yelling at him. And that's just not how. Oh, there should be some more animations here, but that's just not how it can work. We need a new treatise on how we deal with these type of new technology, these wonderful technologies. You have the city councilmen yelling at the Uber, I mean, that's insane. And so we got to change the dialogue, I think, too, because it's this everybody thinks Big Brother, with this dynamic. If people know where you're going before you go, people get a little weird. But no, Big Brother is helping. We're trying to implement this better and make it, the world a better place. And Rome was built in a day, I like to say. Uber showed up like that. I think what's going to happen is the driverless car, the device of the future, is just going to show up, and these companies are doing it today. And rather than fighting them, we need to, as governments, as agencies, we need to work with them. And the amount of money that is lost due to car accidents and can be saved with this technology is in the billions of a year. That could buy everyone, there should be some more Apple Watches there, but that could buy everyone the device required that we need to implement this technology. These wearable technologies are coming. They're the way of the future. It's the only way. We have this digital skin in our cities, where just so much vast amounts of information are being contributed. And you're contributing information right now, whether you know it or not. And we can take that data and we can create these intelligent networks and understand where people are going before they go. I mean, right now, everybody just feel in their pocket. You're wearing a computer already. And in the future, when we're wearing these devices, it can be an integral part of our transportation movement and how we get around. So, thank you.
All right, so Adam, from Will Smith and I, thank you for promoting the iRobot Auto Mall. Thank you very much. Okay, so coming up next, we have, dun dun dun, Bryan Wilson.
Level 3 to drop off your winning ticket.
Just gonna wait a second while they finish their announcement. Envision a world where vehicles are cleaner and cost less to run. Envision a future without air, noise, or visual pollution. Now let me show you how to get there. 150 years of industrial progress has left us immersed in pollutants that are bringing destruction of the environment. We propose electrification of ground transportation systems as a means of cleaning up both the production and consumption of energy. Current transportation challenges include eliminating emissions, reducing operating costs, reducing maintenance costs, and simplifying drivetrains, and doing all of this with equal or better convenience. According to Clean Technica, in a recent apples-to-apples comparison, electric buses are the best when it comes to health, greenhouse gases, and cost. So for dense urban areas, electrification of bus transit seems like an obvious idea. This isn't a new idea. This was introduced in the 1880s, commercialized in the 1920s, still in use today, with manufacturers planning more for the future. It's clean, it's quiet, it's healthy. So what's the problem? Wires. Current commercial electric vehicles require ugly overhead infrastructure. Not only ugly, but high maintenance. Well, can we use batteries instead? Batteries have their own problems. Size, weight, and cost for starters, and battery life is less than vehicle life. And plug-in charging demands downtime. The current battery electric bus model requires loading up the vehicle with all the batteries you'll need for the entire day, 300 kilowatt hours, a staggering 8,000 pounds, equal to 45 passengers before anybody gets on the bus. How are we going to solve the battery problem? Ever since the discovery of electricity, scientists have sought to transfer power without wires. 100 years ago, Tesla envisioned a world where vehicles would operate freely on wireless power. This vision inspired breakthrough technology that the World Economic Forum called a top 10 emerging technology. It was also voted by Time magazine as one of the 50 best inventions. Called shaped magnetic field in resonance, this breakthrough technology allows high power to be transferred wirelessly to vehicles either stopped or in motion, turning regular stops into convenient charging opportunities. The infrastructure is simple. A roadside inverter takes grid electricity and converts it into a magnetic field generated at a road-embedded pad. And then a pickup on the bottom of the vehicle converts that magnetic field back into electricity. Once inverters are installed for initial users, the system can be easily expanded for other vehicles, either stopped or in motion, all switched seamlessly via on-vehicle RFID. And for those who would say that electricity production is dirty, I say poo. I mean point of operation. With EVs, the urban poo is instantly relieved of smell, noise, and unsightly mess. And as the grid gets cleaner, EVs get an automatic upgrade. Another electrifying benefit for fleet operators is both the reduction and stability in operating costs. Oil price volatility can blow up any fleet budget. By comparison, electricity prices are relatively low and stable over time. This isn't some Buck Rogers or Jetson's idea of the future. Commercial wireless systems are operating in Korea and have been since 2011. The easy way to electrify our roads would be to start with regular city routes. City bus routes, bus rapid transit, campus shuttles, and school buses. And then once a network of inverters is in place, additional charging pads can be added for other electric vehicles. Garbage trucks, delivery trucks, corporate shuttles, hotel shuttles, taxis, and utility fleet vehicles, all of which are currently available in electric variants. Some of our visions of the future have already been realized, for better or worse. Here's a 50s vision of the future, where cars get their power directly from the road for clean, efficient cities. Let's not miss this opportunity to make a better world. Charging the transportation system will reduce well-to-wheel energy consumption and help save the environment. It's time to charge up the road for a dynamic future. Thank you. Thank you.
Well, I'm sure Thomas Edison and Henry Ford are smiling at your poo right now. All right? All right, so last but not least, coming up, we have, I got this because I wrote it down so I could say it almost perfectly, Surumi Hamasu. Okay.
Go ahead. Okay.
Here we go.
Hello, my name is Surumi Hamasu, and I'm from Waysign. Imagine real-time signs at every bus stop, just as we have at airports and train stations today. Our innovation, the Waysign, has a great story. And I hope by the end of my presentation, you'll be able to see how Waysigns can transform bus stops everywhere. Real-time signs are great because you don't have to ask the question, where is the bus? You know where the bus is. You can wait for the bus, have a cup of coffee. In Houston, you can ride your bike to a destination. I lived in London when real-time signs came onto the scene, and I thought, oh, wow, this is cool. And I took the bus more often. It's basically advertising my bus is going to be there in 2 minutes. Then I moved to Hawaii, and I saw how Waysigns transform humble, ordinary, everyday bus stops into dazzlers. We're creating a bus stop utopia in Honolulu. Modest, everyday signs are being transformed into rainbows of information. How did this all start? I will tell you the story. Roger Morton of Oahu Transit Systems really valued the hardworking Honolulu bus stop signs, but we have rail coming, so he knew they would have to work even harder. He saw in his travels solar real-time bus stop signs, and while he thought this was a really good idea, he couldn't find any of them that would fit in Hawaii. They were all too expensive. So one day, he called his friend Carl Chang. Carl Chang had created the Verifone and cut the costs of credit card processing to a fraction. Roger wondered, could Carl do this for real-time signs too? Little did he know, in Carl's heart, there was a vision for an affordable real-time sign. Simple, yet intelligent. Beautiful, yet robust. And he found a team of people to help him with the vision. We undertook the challenge of energy collection because not everywhere is as sunny as Honolulu. So we squeezed energy out of the sun to make the Waysign work. We balanced this with energy usage where we use LCDs, LEDs, data transmission takes a lot of energy. enunciators take energy. We have all of these features being worked into the way sign. Our goals were to make it affordable. So we reduced installation costs by making them completely wireless and solar. We also reduced data costs. We want the way sign to be a part of the Internet of Things. We want to support smart city applications and machine-to-machine capabilities. So we designed the way sign with a 900 megahertz ISM mesh radio with Wi-Fi and cell phone support to reduce data transmission costs. We built it with a robust aluminum enclosure. And we also put on 3M graffiti tear-off sheets to protect against vandalism. Here is the quick mount. It's a unique design that enables the sign to be put right into an existing bus stop pole. And these are small solar panels. They're very efficient, and they enable our batteries to last over a year, even though there's only partial sun required on the sign. So a half day of sun will get it to work. We invite you to come to Honolulu because we're having a pilot starting in November. We're turning Honolulu into a bus stop utopia. We also invite you to our booth. We're just out here in 7812, and we would love your feedback because we want to bring real-time signs to every bus stop and make this a reality. Thank you.
Hi, everybody. We're going to bring up our three judges, and they're going to give just a little bit of feedback on the presentations and offer their input on their selection for the choices. But again, I can't emphasize this enough. We appreciate all the presenters. We think all of your ideas are excellent. And so this is really about celebrating innovation. And so not so much about winners or losers. Again, everybody's a winner, which is what I always say. Everybody gets a participation ribbon, but you really do. So thank you again, truly, and I hope you have a great time here in Houston and a great time at the conference. Thank you. Also, one quick reminder, immediately after this, we're going to have a happy hour reception. It's going to be at MKT Bar, which is 1001 Austin Street, which is very close. It's within walking distance, so everyone is welcome. APTA has been gracious enough to cover the first drink ticket for everybody who's attending. So we should have a good group, and hopefully all of the contestants are there to also celebrate with us. So thank you.
Tall here. There we go. Thank you all for coming. I'm going to be kind of just wanted to briefly reiterate some of the things that people have said, but also add a little bit to it as well. We're really honored to be able to partner up with APTA to get this done as well. All the presenters deserve a lot of credit. 5 minutes, 20 slides, 15 seconds per slide is not easy. I've done it before. It is terrifying. It takes a lot of practice, an incredible amount of practice to execute it, and I think that all of them would probably vouch for that statement and agree with that as well. I can't imagine how much time they spent in front of the mirror. Also, thank you to all of you that attended, because a speech without an audience is not really a speech at all. And thank you very much to the production crew as well, who captured all of this on video along with slides. So thanks very much. Also, hats off to Nick for putting all of this together. He's worked tremendously hard in facilitating all of this. I know that firsthand. So thanks very much, Nick. Thank you to John for being an excellent MC. I appreciate it. And thank you very much to my fellow judges as well. We're really, really fortunate to have them here to lend their credibility and expertise in transit to all of this. So thank you, gentlemen. We had 3 different awards. This is not a first, second, third. These are 3 entirely different categories, just to be perfectly clear. I give you all first place. So My job, being the person who knows the least about transit as a whole, but perhaps specializing more in speech than anything else on the panel, was to focus on best overall presentation. It was purely a matter of execution and making sure that the person who gave the tightest speech, the person who used language most effectively, the person who focused on a good combination of storytelling, excellence in visuals, and a general engagement and magnetism with the crowd was the person who received this award. So that was all I was really focusing on. And there were a few that definitely did a really, really good job. And in fact, if you want to ask me about it, I'm very, very happy to give feedback. Any way that I can help you improve in general in presentations, which is the thing that I know most about, I'm happy to help you do. But today's best overall presentation, I'm going to go ahead and say it was Bryan Wilson. I thought it was the most polished.
We'll save the president for the final award here. We had a lot of discussion about the most innovative public transportation concept, the most innovative concept out there. And we had a lot of folks that, all these concepts were innovative. It's very difficult to see which one would be most innovative. But we started thinking about not only innovative, but transformational. And we had several that were that as well. From the bus signs to the Hawaii, your system, where's Hawaii? Yeah, the Hawaii system, that's a cool little deal. It's transformational in its way with the Utopia bus. We actually have a Utopia, Texas. It's about 180 miles to the west of here. The automated maintenance systems are incredible, and people kind of discount the importance of automated maintenance systems. But the most totally transformational award we looked at that came up with was the Intelligent Luxury People Conveyor system. and so we think that on-demand kind of personal rapid transit is a great deal. So Zhiting, congratulations to you. Congratulations.
Okay, by the way, I was slightly misrepresented. I am not the chair of APTA. I am the past chair of APTA. I have been for the last 2 days. So after that, you keep adding days. Yeah, this is another one that we had to talk about and think about, which is the most realistic proposal that could be implemented today. And so really this is a tough one because there were actually 4 proposals that could be implemented today. So, the question really is, by what time then? Is it in the morning, in the afternoon, in the evening, or at night? If it's in a day, how could we do it? And there was some really good thinking in this area, and that's really very valuable because the speed with which we can do something sometimes is more important. It saves us a lot of money and a lot of time and aggravation. And the one that I think, the one proposal that really lends itself to speed is the one that can easily be implemented because a lot of young people who know about technology can start moving it quicker and developing the apps. So it would be Laura Graham's proposal that meets that objective. Thank you, Laura. Oh, and by the way, I'll be at the reception later. I will be there, and I'll expect to get the drinks and have the conversations. I do have to go to someplace else before that, but after that, I'll come over there, okay?
Thank you. All right, so as we bring this to a close, the one thing I want you to take with you is to understand that just being here today and taking the time to prepare this has placed you one step closer to obtaining what was not possible at one time. And as I spend the majority of my time with entrepreneurs and people with passion, I always feel like I'm in a very safe, I'm like the bumblebee in Rain, the video, to be in the field with you guys, because it's just always incredible to think that you took the initiative to step outside the box, break the comfort zone, and do something this amazing. And like you said, get up here and come up with a whole lot of words in 5 minutes. So once again, thank you for coming out. Thank you for allowing me to be here with you. Thanks, Nick. Thank you to the judges. And now let's go have some fun.